Hello and welcome to another presentation, this time on coordinate geometry. So, much of the coordinate geometry in AS level does overlap with the material from GCSE. The following results which I'm about to go through should be very familiar. No doubt about it, a year 11 student needs to know all of this in the GCSE, but it also comes up in the A level as well. So let's have a look at some of these results. Firstly, if we've got 2 points, A being x1, y1 and B being x2, y2, we've got the gradient. Now the gradient is often taught as rise over run, but it can also be taught as y2 minus y1 over x2 minus x1, or indeed change in y over change in x. It's a fairly straightforward concept and they learn about it probably in about year 9 actually, the gradient. Next up is the midpoint. Now the midpoint I simply describe as the middle of the x's and the middle of the y's, and if you're going to find the middle of the x and the middle of the y's, the easiest way to do that is to add them together and divide by 2. So the midpoint will simply be x1 plus x2 over 2 and y1 plus y2 over 2. Next up, we've got the distance between 2 points. Now this should certainly remind you of Pythagoras' theorem, and ought to say, notice to the power of 0.5, it's normally written as a square root sign, but I had some problems with the formatting there, so yeah, I've put to the power of 0.5. But this is Pythagoras' theorem, essentially. The x2 minus x1 represents one side of the right angled triangle, the y2 minus y1 represents another side of the right angled triangle, then we're squaring them, adding together and square rooting to find a distance between 2 points. We've also got this formula. Now this isn't often shown to GCSE students, I believe. I'm not sure actually. I mean, I often just teach them y equals mx plus c, but I tend to introduce this at A level, but I'm sure other teachers will disagree and show them this at an earlier stage. It's simply a reworking of y equals mx plus c, and it's a little bit more convenient if you have an awkward gradient which happens to be, you know, a bit of an ugly fraction or something like that. It's sometimes a little bit easier to use this format. Last up, we've got perpendicular gradients. Perpendicular gradients m1 times m2 will equal minus 1 if those two gradients are perpendicular. A slightly different way of putting this is to describe one perpendicular gradient as the negative reciprocal of the other perpendicular gradient. So if you've got a gradient of 7, the perpendicular one would be negative a seventh. If you've got a gradient of 3/4, the perpendicular gradient would be minus 4/3. So it's a case of just turning the fraction upside down and changing the sign. Okay, let's actually have a look at the at using this formula on 2 points that we're given. Let's say we're given a point A, which is 1, 2, and a point B, which is 4, minus 5. Let's quickly remind ourselves how to find a gradient. It is simply rise over run, which will be y2 minus y1 over x2 minus x1. It gives us minus 5 minus 2 over 4 minus 1, which gives us minus 7/3. What about the midpoint? Well, just as easy, just find the middle of the x's by adding them together and dividing by 2, middle of the y's, exactly the same process, and we end up with 2.5 and minus 1.5. Distance, well, here we can really see Pythagoras' theorem. If you look at the change in y there, we've got a gap of 7 there. We're just finding, when we do y2 minus y1, we're just finding the length of AC there. Same with x2 minus x1, we're just finding the length of BC, sorry. We then square those sides and add them together and square root to find the length of the hypotenuse. So all distances is a reworking of Pythagoras' theorem, and in this situation it's going to give us 3 squared plus 7 squared, which is root 58. Okay, what about the equation of the line AB? Well, we've got the gradient. We've also got a point which lies on the line. I'm going to use the point A, but you could have used just as successfully the point B, and I'll leave that as an exercise which you can do on your own if you like. Try doing this with B, you should get exactly the same answer. What I'd probably do at this stage though is multiply by 3, just because I've got minus 7/3 there. It gets rid of the fraction. I then multiply the minus 7 into the bracket, rearrange and simplify, and I get the final answer that the equation of the line AB is 3y plus 7x equals 13. Now let's look at circles, because The way this comes up in AS level is they have a lot of coordinate geometry, but it will be in the context of maybe a calculus question, or maybe a question on circles, or maybe a question on factor theorem, maybe you're using some principles of how quadratics are sketched, that kind of thing. Okay, so let's have a look at the general equation of a circle. Given a circle, centre AB, radius r, the equation of the circle is going to be x minus a squared plus y minus b squared is r squared. This is really just an extension of the equation of a circle which they learn at GCSE. But the equation of a circle they learn at GCSE is always centre 0, 0, and it's simply x squared plus y squared is r squared, because a and b are 0. So it's a very easy idea to extend the GCSE learning here. It's really just a function transformation as well. That's all that's happening here. We're just transforming the function and moving it a few to the, well, a units to the right and b units up. Okay. Let's give an example of this. Here's a circle, its centre 2 minus 1, and its radius is 3. From the centre to the edge, the radius is 3. So that would give us an equation of x minus 2 squared, because the x component of the centre is 2, plus y minus 1 squared, well that becomes y plus 1 all squared, and then it equals the radius squared, which is 3 squared, which is 9. So that's an example of the general equation of a circle being used. Let's look at a few questions now. We're going to take you through 3 examples. Example 1. Let's find the equation of the circle passing through 3 minus 7 with centre 2, 3. Well, we're given one piece of information here because we're given the centre of a circle. So let's plug that into our general form for the equation of a circle straight away. That becomes x minus 2 squared plus y minus 3 squared is r squared. We still need to work out r though. Well, r's not too bad because we've got a point on the edge and we've got the centre point. So if we find the distance between those two coordinates, we should be able to find r, and hence we will know r squared. Well, r squared is going to be equivalent to the gap in the x's squared plus the gap in the y's squared. That gives us r squared equals 1 plus 100, which is r squared is 101. And hence I can now write down the full equation of the circle. It will be x minus 2 squared plus y minus 3 squared is 101. Fairly straightforward one there. Okay, let's have a look at another question. This one is a little bit different, but it's quite typical. Here we've got find the centre and radius of the circle with equation. X squared minus 6x plus y squared plus 10y minus 2 equals 0. And we've got to try and find the centre and the radius. Now at first glance it doesn't look like it's a circle even, because it's not in that standard form. But actually all we need to do is just complete the square on these first two terms and complete the square on these second two terms. So I need to complete the square twice. Now if I go ahead and do that, if I take, let me just draw on this, if I just look at x squared minus 6x, halve the middle term to get x minus 3 squared, but then you always subtract that which you've got in the brackets when you're completing the square. If you've seen my completing the square videos, that will make a bit more sense, but we always take away that value squared, and that gives us x minus 3 squared minus 9. And if you multiply out that bracket and then take away 9, you'll see it's the same as x squared minus 6x. Exactly the same process on y squared plus 10y. We're going to make that y plus 5 all squared because we've halved the middle term. Then we're going to take away 5 squared, which is 25. Once again, multiply out the brackets and simplify with a minus 25 to see if it does in fact equal y squared plus 10y, but it should do. Now once you've done that, all you need to do is dump, if you like, all the other numbers, the minus 9, the minus 25 and the minus 2, onto the other side of the equals. And then it becomes really clear that the radius is going to be 6 there, because that's r squared, remember, not r. And the centre is going to be 3 minus 5. Don't forget to change the signs of the values inside the brackets. And that's a fairly typical circles question. Okay, I'm going to finish off with tangents and normals. A question about a circle's tangent and normal. Let's say we've got a circle, as shown in this diagram, with centre 3, 3. Now it also passes through the point 4, 1, and all we're going to be asked to do is find the equation of the tangent at B first. Now there is a routine to this problem. You could use implicit differentiation if you've done A2 maths, or you recall how to do that in A2 maths, but it's actually easier this way round anyway, I think. We need to first find the gradient of AB. Now, if we can find the gradient of AB, we can easily establish the tangent gradient, because the tangent will be at right angles to AB. It will be perpendicular. And so we can use the principle of perpendicular gradients to establish the gradient of a tangent. The gradient of AB is pretty easy to work out. We can use our y2 minus y1 over x2 minus x1, and you can see that gradient's minus 2. It looks like minus 2 as well, because if you look, we're going across 1, down 2. That's a gradient of minus 2. And therefore, the perpendicular gradient is going to be the negative reciprocal of minus 2, which becomes positive a half, which is 0.5. Once I've got that, I've got the gradient and I've got a point on the line, so therefore I can use y minus y1 is m times x minus x1, where y1 is 1, x1 is 4, and the gradient is a half. All we need to do then is tidy it up a little bit. I'm going to double both sides, and that leaves me with 2y minus 2 is x minus 4, and then I'm going to add the 2 over, so I get 2y is x minus 2. And that's done it. Never hurts actually to just quickly plug that point in, or another point you might know which is on the line, just to check that it does indeed give you, that the x and y criteria are satisfied. Okay, that's the first part of the question. My next part is going to be a little bit different. It's exactly the same diagram, but now I'm going to ask, given that the tangent intersects the y-axis at D, find the area of triangle ABD. So this crossing point is D, and we're trying to find the area of the triangle ABD. In fact, I might just quickly draw that on there with a bit of an unsteady hand. We're trying to find the area of, sorry about the non-straight line here, that's a bit better, the area of that triangle there. And at first glance this might look quite difficult. Now D you can obviously find either by using the formula and just setting x equal to 0, or you could just look on the diagram here in this case and you can see it's at 0 minus 1. But the way we're going to find the area of this triangle is we're going to use the fact that it's a right angled triangle from circle theorems. And so all I really need to do is work out this distance and of course the distance up here, which is, oh sorry about that, it's all got a little bit messy. I think I might have to get rid of some of my annotations there. There we go. But let me just try and draw that again. Yeah, all we're really going to do, you see, is just find the area of this triangle by finding the length of those two sides. Ooh, even worse drawing this time. I don't think my tablet's very steady. Anyway, let's get going, because otherwise we'll be wasting too much time. Okay. The length of AB, I think you get the idea anyway. The length of AB is going to be root 5. Now how do I work that out? Well, I just turn it into a right angled triangle and use the distance formula. It's 1 across, 2 down, so we need to do 1 squared plus 2 squared, square rooted. That gives me root 5. Same for B to D. We've got 4 across, 2 down, so that's going to be 2 squared plus 4 squared. That's going to be root 20, which you can simplify to 2 root 5. Now we have to do is multiply the length of AB times the length of BD times a half. And if you do root 5 times 2 root 5 times a half, you get to 5. And so the area of triangle ABD equals 5. Okay, that completes the presentation. Hope that all makes sense and reminds you a little bit about how circles work. Best of luck in the unit assignment. Bye bye.